Imagine, for just a second, the absolute logistical nightmare of developing and testing a COVID-19 vaccine for millions of people worldwide. I mean, the challenge of figuring out if it's safe and effective for everyone is just staggering, right? Well, welcome to this explainer. Today, we're going to unpack what I like to call the great data collection dilemma, the epic, ongoing battle of census versus sampling. Seriously, think about it. How do we actually know if millions of vaccines work without testing, well, millions of people? We simply can't run clinical trials on every single individual on the planet all at once. It's geographically, financially, and temporally impossible. So how do we solve this massive core problem in research without just, guessing? Okay, let's dive into this. Here's our roadmap for today. We'll start with the data collection dilemma, then contrast population versus sample. After that, we'll weigh census against sampling, check out a super cool real-world example with Frito-Lay, and finally, learn how to navigate those tricky sampling pitfalls. All right, Section 1, the data collection dilemma. And what's absolutely vital to grasp here is that this isn't just about vaccines and medical labs. This incredible data dilemma applies to practically every single aspect of modern research, manufacturing, and industry. Let's look at a really practical, everyday question. What percentage of supermarket chicken is contaminated with salmonella bacteria? Just picture the sheer absurdity of trying to test every single piece of chicken currently sitting on a supermarket shelf. I mean, by the time you finish testing them all, your data would be totally outdated, the cost would completely bankrupt the producers, and frankly, you wouldn't have any chicken left to actually sell to consumers. There is literally no experiment you can run to answer these types of questions by testing absolutely everything. So to solve this, we have to rely on a solid theoretical foundation. Section 2. Population versus sample. This right here is where we introduce the ultimate hack to solving our impossible data collection dilemma. The difference between these two concepts is fundamental, but honestly pretty simple. The population is the massive group you want to study, literally everyone or everything involved. But since testing everyone is impossible, as we just established, we extract a sample. And that's just a focused, manageable subset of individuals who actually participate in the research to represent that larger whole. And this brilliantly illustrates how the magic happens. By systematically extracting a really well-chosen, representative sample from that massive census population, researchers can infer vital, accurate information about that huge group without the staggering workload of investigating every single person. It fundamentally slashes costs, it dramatically saves time, and it's what makes gathering high-quality, actionable data actually possible in the real world. Which brings us to Section 3, census or sampling. Let's take a moment to directly compare the two primary methods we can use to actually gather all this data. Looking at this side by side really reveals the stark trade-offs we're dealing with. A census is basically an attempt to enumerate the entire population. Now, it boasts incredibly high accuracy and highly detailed, comprehensive data. There's zero sampling error, simply because no one is left out. But the drawbacks are massive. It is wildly costly, incredibly time-consuming, and just logistically overwhelming, especially for large populations. On the flip side, sampling is highly cost-effective, time-saving, and totally feasible. The catch? Well, it inherently carries a potential for sampling error. If it's not done perfectly, your findings might not represent the whole. But, as we're going to see, those sheer logistical nightmares usually make sampling our only practical choice. Okay, let's step away from the abstract theory for a minute. Section 4, real-world example, Frito-Lay. We're going to anchor these concepts right on the bustling factory floor of a massive manufacturing plant to see exactly how this works in practice. So imagine a massive delivery truck hauling 45,000 pounds of raw potatoes pulling up to the Frito-Lay plant. They don't just blindly unload the whole thing and hope for the best. First, a 150-pound sample is carefully extracted from entirely different locations within the truck. We're talking some from the front, the middle, and the back. Next, an inspector takes exactly 40 pounds of those specific potatoes and punches a hole right through their core so they can be easily spotted later on. Then, these specific, core-punched potatoes undergo a cooking test. Think about that for a second. The entire fate of a multi-ton shipment is accepted or rejected based entirely on this incredibly specific, rapid sampling process. But the data collection definitely doesn't stop at the loading dock. All along the production line, workers are continuously taking samples. They're actively weighing defective potatoes. They'll pull sample chips right off the line to meticulously measure them for exact thickness, color, and salt content. Even the finished bags are sampled to check their precise weight before and after being packed into cartons. You see, if Frito-Lay waited until the absolute end of the line to inspect the finished product, minor problems could compound into massive disasters. Sampling at key points throughout production catches issues early and keeps the whole process perfectly on track.
And here is where the absolute necessity of our dilemma really sets in. This process is known as destructive testing. Just think about the sheer absurdity of it for a moment. If you insisted on taking a true census of Frito-Lay's potatoes, meaning you literally peeled, cooked, and tested every single potato on that 45,000-pound truck, you would literally destroy your entire product line. You would be left with exactly 0 potato chips to sell to the public. In scenarios like this, sampling isn't just a clever cost-saving measure, it is absolutely essential to surviving as a business.
However, as magical and super efficient as sampling is, we do have to be really careful. Section 5. Navigating sampling pitfalls. This whole system only works if we successfully avoid some massive mathematical traps along the way. Without a doubt, the single biggest trap of all is sampling bias. By definition, this occurs when a sample is collected in such a way that certain segments of the population are systematically excluded, or conversely, heavily overrepresented. It's a critical structural flaw. If your sample selection is biased right out of the gate, your findings are not going to accurately represent the whole population, and that leads to completely inaccurate conclusions and totally wasted research. To firmly ground this concept, let's look at a classic, everyday example, the voluntary television poll. When a local news station asks viewers to call or text in to vote on a hot-button issue, it immediately creates a systematically flawed sample. Why? Well, because it's voluntary, only people with extremely strong views are motivated enough to actually pick up their phones. Plus, it entirely excludes the massive segment of the population who simply aren't watching that particular station at that specific time. It is a textbook case of bad sampling. So, how do we actually fight this trap? We bring out the statistician's ultimate weapon: simple random sampling. This is a brilliant method where the sample is chosen in such a way that every single individual in the population has an exact equal chance of being selected. By letting pure probability drive the selection, we systematically eliminate the chance of favoring any specific outcome. It is literally the gold standard for study design. So the crucial point here is that building a perfect sample requires incredible discipline. Researchers have strict rules and constraints they must follow to ensure their sample actually generates valid, reproducible truth. They have to clearly define the exact target population. They need to create a comprehensive, up-to-date sampling frame to draw from. They've got to ensure a sufficient sample size for real statistical power, actively mitigate things like non-response bias, and definitely address ethical considerations like privacy. It's an exact science. Which brings us to the end of our explainer. You now know that behind every single data point, every vaccine efficacy rate, and every bag of perfectly salted chips, there was a meticulous decision about who to include and, more importantly, who to exclude. So I want to leave you with this final empowering thought. The next time you see a flashy statistic popping up on the evening news, use your new critical thinking skills and ask yourself, who was left out of this sample? Thanks so much for joining me, and keep exploring the data.